My name is Daniel Wilson, and in this video I'll be presenting my master's project, SPLAT. SPLAT stands for the Schenck Process Layout Automation Tool. Schenck Process is a company, and the type of layouts we're going to be automating are pneumatic conveying layout models in Inventor. The main driver for this project is time saving. We're going to save the time of the engineers to create these drawings, making them customers faster to get these models and plan them into their systems, because we can create them instantly, and giving the power to salesmen to create these models as well, and taking that functionality out of the engineering department. So I'm just going to jump over to SPLAT, which is hosted within a CPQ software called Camos. I've used Camos in this project. I'm going to reshare my screen. I've used Camos in this project, but this could be created in Excel. I'm using Excel anyway to hold the values in between Camos and Inventor, which I'll show after I've created them. We have a number of configurators at Schenck, and it's just hosted within the same environment. So I've made this configurator. And on this first page, we fill in the global settings for the system. So flange standard, PN10, PN16, that's all I've got at the minute, a pipe size, a material, and a wall thickness. Now, the pipe size and the wall thickness and the flange standard are going to affect the physical properties of the component in space. So, increasing it in size, increasing the thickness of the pipe wall, whereas the changing the material is just going to change the function in eye properties. So the next tab here is then the pipe routes. This is going to be where you create your system-specific pipe run. I want to start mine with a prophase pump, which is a pneumatic conveying pump. Now, I just have one of these in for each size, so it's kind of representative of the rest of the range and indicative of what SPLAT can do. So we can, of course, put in any number of these. It's relatively easy to place or to offer new components within SPLAT. It's not too difficult to code them in. So we've got a pneumatic conveying pump now, so we're going to create a pipe route. So let's say a 10-meter run. And now let's put a bend in. So you can either choose 0, 90, 180 or 270 here. I've got a little bit of help here. So if from looking at the perspective along the x-axis, the pipe is laid in the x-axis and you're stood on the end of the pipe. 0 degrees would be directly up, 90 degrees to the right, 180 degrees to the left, and 270 degrees downwards from that initial pipe run. So if we say we want to go up, then we're going to be able to select the 0 degree termination. So let's have a pipe route in between them, a vertical rise of 15 meters. Then another bend, so 180 degrees gets us back to the same X orientation that we had at the start of this configurator. So I'm adding a short 3-meter route here, and then we stick a terminal box on the end. So you can see here that the this table represents the system we've just created. If I click Export System. Okay, so what's happening now is for each of these components, the SPLAT is calculating a homogeneous matrix for each component, homogeneous transformation matrix, which is then read in by Inventor to place each component at its given location from the base location. So from 0, 0, 0 in Inventor, it's then going to place each component in from its homogeneous transformation matrix. So I'm just going to hop over now to my downloads file. I'm just going to open that file that we created, that Excel sheet. So I'm going to reshare. Okay, this is the Excel sheet that we just created. So column E contains the file names of the parts we're going to place in order. And to the right of them is the 4x4 homogeneous transformation matrix used to position it within Inventor. The transformation matrix describes the location and orientation of the component from the base point 0, 0, 0, or whatever it's defined as in Inventor. In this case, it is 0, 0, 0. Yeah, so you can see here in column E, that part is going to be placed at this location as arranged in a 4x4 matrix. Okay, we'll go back to, so each component is being placed at its matrix location, and hopefully we're going to have a pipe run, a vertical bend, a vertical section, a bend back to the same orientation in which we started, another pipe run, and then a terminal box. So each time it says retrieving information from SPLAT, it's placing a component, and here we are. So pipe run in the horizontal, a bend into the vertical, another pipe run, bend back into the horizontal, a terminal box. Yeah, it can create much more complicated systems than this, and it just takes a minute or two to run. As it has to go through that loop, it just takes a few, 2 or 3 seconds each time. Thank you for listening.